Hey, welcome to the first physics video in the kinematics, which is just the science of describing motion unit, our first unit in physics. I'm going to be going through a little bit of the terms and the equations for you. And this video is primarily for the kids that are in the B group, so the ones that can't be here on the first day, or the kids that are doing the full distance learning. But whoever you are watching it, hello, I'm Mr. Dewey. You're going to want to watch this whole video because I am using this to take attendance through Edpuzzle. So if you watch the video, I'll be able to know. But I am anticipating that you're going to be fascinated with the stuff I'm going to show you. For one thing, you can see my screen, and that's really all you would need to see. But I have included myself in the bottom left corner for you and my screen again. So you can see my screen tiny and you can see my screen big and you can still see me. So you know I'm really the one that's doing the things on the screen. So what things am I going to do? Well, first of all, I want to show you in the Google Classroom that we have a syllabus and we have Kinematics Notes as some class materials. I'm hoping to put more things there. And then you have your daily assignments. Have the information for the day. So today is September 8th, so you would click on that one. It would give you motion worksheet number 1, which is really a good time, and you're going to use some of the stuff I'm about to teach you in doing that. But this sheet right here, Kinematics Notes, is a very important one for you. And I have some for those of you that are going to be in person that you can have. Otherwise, you could print this out. So it has all the terms from this unit, and then it has some equations. There's one constant velocity equation. You learned it in 9th grade. It's V equals D over T. And then there's 4 different equations that we're going to be using for acceleration. And I'm going to be going through a little bit about those equations for you. So I'm going to switch over to Smart Notebook so that I can do a little writing, and we'll go through these things. So there's 2 types of motion. The first type is constant velocity. And the second type is changing velocity. Everybody at all times has one of these 2 types of motion. So right now, I'm demonstrating constant velocity motion, because when you're not moving, that's constant velocity. Or if I had my cruise set going down the road at 60 miles an hour, that would also be constant velocity. Changing velocity would be when I'm speeding up or I'm slowing down. Or there's actually one more thing that would be an example of changing velocity, and that would be if I'm turning. Because velocity is a special word called a vector. And what a vector is it's a magnitude and a direction. So remember, the orange pajama guy from Despicable Me was committing crimes with both magnitude and direction, and his name was Vector. It's not just how fast you're going, but it's also the direction. So if you're going backwards at 30 miles per hour, that is not the same velocity as forward at 30 miles per hour. The direction matters for velocity. So anytime you turn, you change direction. So by definition, turning is changing velocity. And this is a really important concept for physics, because if you have a changing velocity, that's the kind of motion that we can feel. Like you can feel it in your belly. We call it acceleration. So if for fun your friends put you in their trunk and drove around, every time you were to go faster or go slower or turn, the instant that your velocity starts to change, you would feel that in your stomach. If they never did that, it didn't matter if they're going 100 miles an hour, 1,000 miles per hour, if they never had a changing velocity, then you would never feel it. You can't detect constant velocity. So changing velocity we can feel. So these are fundamentally different types of motion. So I'm just going to list under vectors. Velocity is a vector. Okay, there's another type of quantity called a scalar, and that would be like speed. Scalars is just a magnitude, just a number. That magnitude's a word for how big a number is. So scalars are just a number, and that would be like speed. So we don't care about the direction when we're talking about speed. Right? Most of the time in this class, we're going to use the word speed and velocity interchangeably because we're going to be going in one direction, so our speed and our velocity will be the same, but they're not quite exactly the same. Okay, so constant velocity, we only use the equation v equals d over t. It's the only equation we have for constant velocity, and it can mean speed or velocity, either one. So let's say, for example, I run the 400 meters and I can do the whole 400 meters in 50 seconds. Then I would do a distance of 400 meters, a time of 50 seconds, and my speed would be 400 divided by 50, looks like it's 8 meters per second. That'd be super fast, by the way. And that's really a speed because if you know anything about track, you know that really when you run the 400 meters, you end up not actually going anywhere. You finish where you started. So we need to get a little better definition of velocity besides that it's just a vector. We're going to say velocity is displacement over time. Where speed is distance over time. So they're not quite the same, especially if your direction's changing. One of them, the D, stands for distance, and the other one, the D, stands for displacement. So what's displacement? Well, if you looked at your sheet, displacement is how far you end from where you started. Okay, so if I run the 400 meters, I end right where I started, in track at least. And so my displacement is 0, and so my velocity is actually technically 0 for that whole race. That's too bad because that was a lot of work. But if you ran 400 meters in a straight line, like out in the parking lot, then you would actually have a velocity of 8 meters per second and a speed of 8 meters per second because speed doesn't care whether you went in a straight line or turned or whatever. So just remember that the velocity includes direction. Usually we're not going to be having any lefts and rights. In this particular unit, we're going to call it one-dimensional kinematics. So the only directions you can go in this unit are forward and backward. So we're going to have positive velocities and negative velocities. Forward is going to be a positive velocity, backward is going to be a negative velocity. Okay, so that's for constant velocity. So notice the units here, meters per second. The fact that we are measuring it something per second makes this a special quantity called a rate. So speed is a rate, velocity is a rate. We're going to learn about something called acceleration here in a second, which is also a rate. But anything with time in the denominator is a rate. So if I get paid $100 a day, that's a rate because it's per day, times in the denominator. If water comes out of my faucet at 5 gallons a minute, that'd be really fast, that would be a rate. So anything with time in the denominator is a rate. So don't think that rate and speed are synonyms, or rate and velocity are synonyms. Velocity and speed are examples of rates. All right, so what other units do we use for velocity or speed? Well, meters per second is one, but that's not the only one that we use. We also use kilometers per hour. In fact, if you lived in Canada and you were driving down the road, the signs are all posted in kilometers per hour. So you might want to be familiar with, well, how fast is 200 kilometers per hour? Or how fast is 100 kilometers per hour? Well, if you can convert miles to kilometers or back and forth, then you can kind of appreciate that because we all know miles per hour. We know that like a lot of roads are 55. If you're in town, they're 30. That's miles per hour. Well, 1.61 kilometers is a mile, or 0.62 miles is a kilometer. It's actually 1,609 meters, but I just called it 1.61. But if you run track, they say that the 1,600 meters a mile, that's technically a little short of a mile, but that's what they call a mile. So you could use 1,600 meters, 1.6 kilometers for a mile. Remember that there are 1,000 meters in a kilometer. So if I wanted to convert this 8 meters per second to kilometers per hour, I times by 3.6. Now you might say, why would you times by 3.6? That seems weird. Wouldn't you do something like divide it by 1,000? Yeah, I did that. I did 8 divided by 1,000 to get it in kilometers. But then I realized that would be kilometers per second. And you don't do very many kilometers per second. In fact, escape velocity from Earth is 11.6 kilometers per second. So I don't think we're going to be doing very many kilometers per second. We're going to be doing kilometers per hour is what I want to know about. So I can do 3,600 times as much stuff in an hour as I can do in a second, because an hour is 3,600 times longer than a second. I have had many students think that there's 60 seconds in an hour. I don't know why that always happens, but there's 3,600 seconds in an hour. So I could turn this 8 into kilometers by dividing by 1,000, but then if I want to get in hours, I have to times by 3,600. So what happens when you divide by 1,000 and then times by 3,600? You really are just timesing by 3.6. If you didn't follow any of that, just remember this. Just multiply by 3.6 and you're there. Okay, so we got 8, carry the 4. 8 times 3 is 24, so 28. So looks like we're going to be going 28.8 kilometers per hour. And this is one thing you should always notice, is that a meter per second is faster than a kilometer per hour. So when you look at the number of kilometers per hour you're going, it should always be much bigger than the number of meters per second that you're going. Okay, if you want to go from kilometers per hour back to meters per second, you just divide by 3.6. So that's an important one for the worksheet you're doing for converting. Okay, we've already talked about some of the non-metric units for speed and velocity. They're like miles per hour, feet per second. So really important to know about constant velocity. Right, changing velocity, a synonym for that is acceleration. And that is the rate of change in velocity, to be exact. Which means that it's going to be the change in velocity over time. Time's got to be the denominator. Why? It's a rate. So we usually use this equation, change in velocity, final velocity minus initial velocity divided by time. That's kind of in parentheses. You got to do that subtraction first. We want the change in velocity. How much did your velocity change divided by how long it took in seconds. And that would give you your acceleration. So notice the units here on this. The change in velocity is going to be measured in meters per second, and then we're going to divide that by seconds. So it's meters per second, which we're going to call meters per second squared. Right? Every now and then you're going to see kilometers per hour per second, but that's kind of ugly. Usually our accelerations will be in meters per second squared. Like the most famous acceleration is the acceleration of gravity. That's 9.8 meters per second squared. So that's the units that we'll use. If it's not in meters, if it's English units, it would be 32 feet per second squared, because 9.8 meters is 32 feet, roughly. Okay, so that's kind of what I want to say about acceleration. Acceleration, that type of motion, means that your speed is changing or your velocity is changing, and it's the rate at which it's changing. So there's going to be 4 equations because we just got more variables. We have your final velocity, your initial velocity, your time, and your acceleration. So I'm going to just really quickly touch on those 4 equations, and then I feel like that will be enough information for one day. But please go back and look at that Kinematics Notes sheet. You can see all the definitions on there. You can see the equations. You're going to have to get familiar with these equations. I don't believe in memorizing anything on purpose, but I do believe in memorizing stuff on accident. So my intention, if I do my job, you will use these equations so many times, the 4 acceleration equations and the 1 constant velocity equation, you will use them so many times that you will memorize them on accident. Okay, so the first one is the one I just wrote down. A equals VF minus VI over T. right? Lots of times we will take an equation like this and we'll solve it for a different variable. So VF equals VI plus AT is how you might see it, right? Another equation that we have is V final squared equals V initial squared plus 2 times acceleration times the distance or the displacement. Usually it'll be displacement. Number 3 would be the distance traveled while you're accelerating is equal to the initial velocity times time plus 1/2 the acceleration times the time squared. That's a pretty complicated one. And then number 4 would be the distance is equal to the average of your initial and final velocity over 2, or V initial plus V final over 2 is the average, times the time. So those are the 4 equations. I'm going to spend a lot of time in my next video on these 4 equations. What I wanted to do today is just point out one thing. So do you notice how this equation here doesn't mention anything about distance? It's not mentioned. There's no D in this equation or this one, either form. These are the same equation, by the way. V final equals V initial plus AT is the same equation as this. Just solve for V final. But it doesn't mention D. This one, number 2, doesn't mention T. It's never mentioned. You aren't looking for it. You're not trying to solve for time, and you don't need it. This one doesn't mention final velocity. And then this one mentions final velocity and initial velocity and time and distance, but it doesn't mention the actual acceleration value. So they all are missing one thing. That's important because we have 5 total variables. We have VF, VI, A, T, and D. There's 5 things that you can talk about when it comes to motion. How fast you end up going, how fast you started, how much your distance or displacement was over the interval, how long it took in seconds, and then the rate at which your velocity changed, your accelerations. There's 5 things we can talk about. That's basically the only 5 things. But to work any of these equations, you can only have one unknown. So if you know 3 things like T, A, and VI, you can find VF. So as long as you know 3 things, you can find the 4th one. So why am I saying all this? Because whenever you get a problem in this class, they're not going to give you 4 things. They're probably going to give you 3 things. And then you have to pick the right equation. Do I pick number 1, number 2, number 3, and number 4? If you can figure out what they didn't mention, did they not mention time? Okay, pick number 2. Was there no point at which they mentioned how fast you end up going at the end, your final velocity? Well, then you should probably pick number 3. So every time, look at what they didn't tell you, and that will help you pick. Many students, when they start doing physics, get frustrated because they'll say, I don't know which equation to use. Once I got the equation, I'm fine. Well, technically, once you have the equation, you're just doing math. Physics is picking the equation. So anytime I hear a student tell me that, what I'm hearing them say is, I don't know how to do physics. Because physics is picking the equation. So right now, what I'm trying to teach you is how to pick the equation. So you look at some information and you figure out, what do I need to know? And what do I have? And then what did they not even mention? Right? So we're just going to try one sample of this for today, and then we're going to get much more of this in Thursday's lecture. The worksheet for today is completely constant velocity problems. Motion worksheet number 1 is all constant velocity. You have to watch the units on it a little bit. There's some kilometers per hour, some meters per second, but fortunately you will not pick the wrong equation. When it comes to constant velocity, you will use the equation V equals D over T. Now it might be in the form D equals V times T, same equation, or T equals D over V, but it's this equation. You will not be picking a different equation, so you shouldn't mess that up. But when it comes to acceleration or changing velocity, remember those are synonyms, you got to pick the right one. So let's say that my question says, I go from 0 meters per second to 5 meters per second in 8 seconds. Find my acceleration. Well, my process, and I do physics problems all the time, and this is how I always do them, is I start writing down stuff 0 meters per second. That sounds like an initial velocity. To 5 meters per second, that's a final velocity. In 8 seconds, that's a time. Find my acceleration. So what I want is an A. So I start looking at this. A, VI, VF, T. There is no mention of D anywhere. No one wants D. Nobody told me a distance or a displacement. Nobody cares. So I'm going to write the equation V final minus V initial over time. Number 1 is the equation I want. So 5 minus 0 over 8, which is 5/8. So 5/8 is something like 0.625. And then it's meters per second squared because it's an acceleration. All right. Now, if I had listed my stuff and there was no time, I would have picked number 2. So that's the process I use for picking an equation. So hopefully that was helpful. I know that's a lot of information for the first day, but you'll find that I will teach same things over and over and over again until you get it. We have quite a bit of time in this unit to learn it. This is all the equations for this unit.